Okay, let's start looking at the SST. The SST, simple Superhet transceiver, was designed by Wayne Burdick, N6KR, first announced in the QRPP Journal spring of 1997. QRPP Journal is available in complete format on the NorCal website. This article is on the web, but it's incomplete because it does not contain the schematic. The reason it doesn't contain the schematic is the schematic was a fold-out. It required 2 pages. QRPP Journal was done by Doug Hendricks as part of the NorCal QRP Club back in the day. Wayne, if you read this article, and I'll repeat some of it, but you need to read it because it's detailed and it has a lot of information that you can use later in life. He was just trying to come up with a transceiver that had fewer parts than the NorCal 40, which he designed. NorCal 40 had 112 parts, and the 40A had 120. They added a couple of things, and the 40A was available as a kit from Wilderness Radio. Now, Wayne was going to do this kit or have Doug and Jim do it, but they were busy with a kit called 38 Special. So he went to Bob Dyer at Wilderness Radio, and he put together a kit for the NorCal Club and the QRPL email list, which I did back in the day as an idiot. And the kit sold for $69 complete, and that's the start of it. Now, these kits listed here show you the number of parts for these kits. And we're going to have to test my memory here because I built all of these. The NW8020 was 150 parts. I think M-Tech was the name of the company. I think it sold for $75, and the guy was, him who did it was Roy Gregson, I think. NN1G is Dave Benson. That's his old call. His new call is K1SWL for Small Wonder Labs. He did a 2-board transceiver that had used a 12 IF 123 IF can, 455 kilohertz, and a bunch of rigs back then did. And then he 2-board, and I built one, and I have a picture of it somewhere, and in this series I'll bring it out. The Northeast 4040 was one of my favorites. I did worked all states on 40 meters with it with 950 milliwatts. This was a kit from Northeast QRP Club, 40 meters, cost $40. Single board, no IF cans. And it was a sweet little rig. It's still one of my favorites. It made the ARRL handbook for 1 year. And it was so simple. It was such a simple transceiver. I didn't understand why after 1 year the ARRL took it out, but they've dumbed down the ham population so much they don't want to build anything. Sorry for the political. I can't keep my mouth shut. Here we go. So that's how the rig got started. Bob's offered this as a kit down at the end. There's a parts list here, but it doesn't have the band information. He offered this kit for $69, and after May 1st, it was $85. Now, where was I going with this? Then, I lost it. That's all right, I'll get it back. Oops. The the Wilderness Radio manual's online, and part of the thing that you need to look at in there is the bands information. Let me make this page fit. Probably needs to be a little larger. It's too large. That'll do. Go and get the manual, print off this band kit, and print off the schematic. Then I want you to take a highlighter, and I want you to highlight these parts, these capacitors, C27, 34, 36, 35, these inductors, the RF chokes. These are molded inductor, and then the crystals. Those are all the components that change from band to band. And you can see that those are the only things that you need to change in going from 40 meters to 40 meter novice to 30 meters and to 20 meters. And you can see what crystals you need, and some of these are going to be hard, if not impossible, to find. But there are some other values that you can use. I'll show you that in a minute. All right, let me get to the schematic. Now here's the parts layout. And somebody, Mike, sorry, Mike, I can't remember his last name. Mike sent me a picture on my phone the other day, and at QRP-Tech, I did a PC board for the SST. I looked through my files. I can't find it. I don't remember if it was what PC board manufacturer or whatever, and if anybody remembers the history of that, let me know. But here's the schematic, okay? Let me rotate it. I don't want to do that. I want to rotate it. Now here's the schematic. Very simple. And some of the parts are going to be harder to find, okay? For instance, this buffer driver is a video amplifier, the LT1252. The only place I can find it is in Europe, and it's expensive. The final PA here is just a transistor like you can find in a system bender. I'm going to switch that. Here's the things we're going to change because they're hard to find. This amplifier, I'm going to go to a 2N3904, just a simple NPN transistor, MPS H10 or something, for the Colpitts oscillator here. And we're going to have to go to SMD devices for the ICs, for the LM386 and these 602s for the mixers. So that's the plan. Now, on the web somewhere is this schematic. This is done by JH1PJL, Kenji. Don't know what year it was done. Oh, yes, it was. He did this in 1997, and he came out with this version, and this is the one we're going to build. But we're going to do some further mods. Now, this is for 40 meters. So the little crystal for the variable crystal oscillator is 11.04. I'm building my SST for 20 meters. I'm going to use an 18.00 megahertz crystal here and 3.932 megahertz for the IF. And I'll explain that later. Now, how does a VXO work? Well, you've got a crystal. If you put an inductor in series with it, it will lower the frequency. If you put a capacitor in series with it, that will raise the frequency. So this combination here fights to determine whether this crystal frequency goes up or down. Well, you put enough value in here, a large value for the inductor. Its inductive reactance is 2 pi F times L. The inductive capacitance reactance is 1 over 2 pi F C. But one's positive, one's negative. In fact, you put a J in front of them because it's an imaginary reactance. But anyway, and so by changing the capacitance, you negate part of the inductance reactance. So this thing for maximum capacitance, it'll have the least effect. This will be the lowest frequency you can go. And then as you decrease the capacitance here, the frequency goes up. So that's the way that works. We're going to science the crud out of this thing. Be like Matt Damon in The Martian. Now, this little transistor here is just a PNP. It's not labeled. Somebody sent me an email saying, what do I use here? Just any PNP. We're going to use 3904. We're going to change this. This is just a NPN transistor, and I'll bring it up. So this is what we're going to use. So go find this schematic, print it off, or you can build the original. If you got an LT 1252, have at it. Every man, child, woman for himself. Let's go up here. Whoops, what did I do here? Oh, okay. One other thing. Go to AA7EE and look at his schematic. Now, he homebrewed the SST. He did it on the web, and here's his schematic. Now, he had an LT1252, so he didn't change anything there. He used an MPRF 237 here for the PA, and he made some other changes. Read his article. Maybe you want to build his. He still used a J310. He used a J310 here. He still used a JFET. Those things are okay, but I'm going to do just a regular transistor. I'm not worried about the extra 2, 3, 4, 5 milliamps of current draw. Oh, if you go look up the 1252 on eBay, here's only two places, it's one place. It's a place in the UK, and they want $23.99 for one chip. It's ridiculous. Plus $8 delivery, and then because of the tariff wars, you're going to tack on another $7. So, okay. Well, here I found on AliExpress the SMD version of it for $3.20. And if you buy some other stuff, buy the crystals, you can get your total bill up to over $10, and you can get it that way, and it's much cheaper than $23, $30. The transistor that was in the buffer driver, it's nothing but an NPN, just has a high collector base voltage, collector emitter voltage of 50 volts. It has a power dissipation of 400 milliwatts. I think a 2N4401 work. One of the things is the HF sub E, the gain of this thing, and there are certain versions here that the gain of this thing is anywhere from 70 to 350 with a max of 240, 400, and I think just a regular NPN in there will work just fine. You may not get the full 2 watts or whatever. What's this thing? Oh, look at the spec sheet on the 1252, and it has a gain of like 38 dB, I think. Well, the gain is set by these two resistors here, but the maximum rating I saw somewhere. Sorry, let's see here. We have any gain dB. Common rejection. Anyway, we'll study this spec sheet. So that's the plan. We're gonna build I'm going to build this one with some mods, and I'm going to have to develop the schematic as we go along. Now, I spent over a week working on my VXO to see what bandwidth I can get out of it. How am I doing on time here? I have eaten up, can't see the 15 minutes. That's pretty good. I think I've covered everything. So here's the deal. You pick a band, 40, 30, 20. You go and look at this schematic, the other two schematics, the original and the one from Dave Richards, AA7EE, and you start drawing your schematic. Also on QRP Tech, Steve Retzlaff, AA7U down in Tucson, Arizona, posted new values for the low-pass filter here so that we can meet current FCC regs. Make sure that your harmonics are down minus 43 dB or whatever. I've been working on the VXO because if you can get this thing to generate a pure sine wave, then this bandpass filter here and the low-pass filter, you should easily meet the specs. One other thing. Dave put a keyer in his. I'm going to put a keyer in mine. He used a tick keyer, I guess. I'm going to use the Kits and Parts 1W. You can use any keyer you want. Some old kits like NorCal and others had single chip kits. Some of you may have some of the K1EL old chips. So we're off and running. Sorry it took me so long to get to here, but it took me a long time to get all the parts and, get my lab reconstructed, and I apologize for that. No excuse, but that's it. Life goes on. We're going to analyze this thing part by part. Look at Dave's work, look at his layout, and we're going to start by first figuring what area, building this thing using Manhattan circuit construction, how much space can you get this thing in? Something like 100 by 100 millimeters should do it. That's the goal. Another modification to the circuit, I'm going to go with the 78L08, up the voltage on the mixers and the VFO. That's it, I'm thinking here. So the keyer is going to be added to this part. We're off and running. So I'll come back. I gotta do one more video on the lab equipment, and that is test equipment, and what are you going to need to build this thing, and we'll be off and running. Thank you for your time. Again, likes, and we're out of the chute.